All right, here's where we're headed today and the next couple of days. Listen up, please. We've spent week and a half basically working on trig identities, getting you to know those trig identities. So hopefully you recognize different times when you've learned some of the trig identities, being able to take a trig identity and kind of simplify it from one side to the other. That's what we've been working on. Really difficult stuff over the last week or so. Okay, there is a purpose for it. Today is going to be, I think you are highly going to appreciate today, because it is not even close to as difficult as what you've been doing the last few days or last week or so. Okay, you're still going to be dealing with trig identities, but not nearly to the extent that you have been so far. So today we're going to look at section 5.3, talking about solving trig equations. Tomorrow we'll go a little bit more difficult, add in a little bit extra difficulty to it, and then Friday will be kind of a work day on a third worksheet. But these shouldn't take you very long, and they're not too bad by any means. So that's what we're going to take a look at today. So you are going to use, when you're solving these trig equations, it's going to be basically right now one of two methods. Okay, most of the time there's one of two things that you do. Both of them are Algebra 2 techniques. Okay, so option number one is if you only have one trig function in the problem, if there's only a sine of x or a cosine of x or secant or something like that, you are going to isolate that trig function. You're going to get it by itself so that it looks like this. The sine of x equals 1/2, for example. Okay, cosine of x equals square root of 3 over 2. Something along those lines. Okay. You're going to basically get it back like what we were looking at the end of chapter 4. Remember when we did inverse trig? And we were trying to find what's the angle measure? The sine of what is 1/2? The cosine of what is square root of 3 over 2? That's basically what we're doing. We're going back to that. Okay? So if you only have one trig function in the problem, or you end up with only one trig function, you're going to isolate that and then solve. Okay? And then at that point, you'll use the unit circle. Most of the time. Okay? You'll use your unit circle. That's why I had you take your formula sheet out. The only time you wouldn't is if you end up with a value that's not on the unit circle. If you don't get like that 1/2, the square root of 3 over 2s, things like that, then I'll show you a different method when we get there. So option one. Option number two is if you've got more than one trig function in your problem, then you're just basically going back to it's a factoring problem. So just like if it was a quadratic, get it equal to 0, factor, use the zero product property, and solve from there. Okay? And I will show you both of those. We'll have examples for both. So one trig function, solve for that function, and then answer the question. Get the answers to the problem. More than one trig function, get it equal to 0, do some factoring and zero product property. And where this relates to what we've been doing, at least for now, you've had some problems in your trig identities where you had to go through and factor. You'll see some similar to that, okay, as you work your way through this. All right. So those are basically your two methods for today. We'll look at a few more for tomorrow. But to avoid, you don't necessarily have to write this down. You just need to know this. To avoid, I have multiple, but really infinite number of answers, we're going to limit the domain to just 0 to 2 pi, just the first time around the unit circle. So we're not going to have something like 13 pi over 6 be an answer, because 13 pi over 6 is more than one time around the unit circle. We're only going to look at the first time around. Okay? We're not going to worry about, what if it was a second time and a third time and a fourth time? We're going to eliminate that. 0 to 2 pi is all we're looking at. Okay? That'll make the problems easier as well. Okay, so with that being said, here's example number 1. Let's do a few examples together. Two sine x minus the square root of 3 equal to 0. So first question I have for you, and the first thing you need to identify pretty much every time you do the problem like this, is this an isolate problem or a factor problem? Isolate. There's only one trig function. It's just a sine of x. So let's get that sine of x by itself. Okay, you're solving the equation. Meaning, I'm going to add the square root of 3 to the other side. Then what? Divide both sides by 2. And what do you know? You end up with one of your unit circle values. And like I said, we are right back to what we did at the end of chapter 4. You're right back to inverse trig again. So now we go to the unit circle, and we are looking for the sine of what angle? What are the angle measures that give you square root of 3 over 2? So if you go back to your unit circle for a second, hold that thought, hang on. First question, and I've got it up here on purpose. We're looking for sine. It's been a little while since we've done sine and cosine and stuff in unit circle. Is sine x or sine y? Yeah, it's right up here. Okay. Sine of x is your y coordinate. So we are looking for, where does the sine of x equal a half? No, square root of 3 over 2, sorry. Square root of 3 over 2. Where's the first one? One of them is 2 pi over 3. And the other one is pi over 3. So we end up with 2 answers. Okay? We've got 2 different places, and there is no other place on the unit circle as you work your way around that has a sign of positive square root of 3 over 2. So we got 2 answers, pi over 3 and 2 pi over 3. And I am going to have you put the answer, the radian measure of the answers in general. Okay? So rather than put it down as degrees, I want you to put it down as pi over 3 and 2 pi over 3. Okay? There's the basic idea right there. Question, Trig? No. You're going to see me put it down as in order because I'm just going to go around the unit circle to find the answers. But if you put them in the opposite order, it doesn't matter. As long as you got the answers. Okay? All right. So there's to at least give you an idea of what we're doing. Let's take a look. Here's the next one. Same first question. Factor or isolate? Isolate. There's still only one trig function there. It's a trig function squared, but it's only one trig function. So add the 3 over to the other side. We've got cotangent squared x equal to 3. Now what? What would we do next? Now we take the square root. I don't want cotangent squared. I want cotangent. Okay? So now we take the square root of both sides. So we have the cotangent of x. One quick heads up, whenever you take the square root in an equation, what do you always have to have? Plus or minus. Don't forget, when you take the square root of both sides, there's more than one possible answer. Plus or minus the square root of 3. And here's one suggestion I have for you in general. If you work your way through and you end up with either a cotangent, a cosecant, or a secant, go one more step and switch them either to sine, cosine, or tangent. And the reason I say that, those values are all on the unit circle. Then you don't have to figure it out. You've got them on the unit circle. Okay? So in this case, I'm not going to stop there. I'm going to change the tangent into, the cotangent into a tangent problem, which means you're just taking the reciprocal. So you are looking for, where does the tangent equal plus or minus 1 over the square root of 3? Or if we rationalize the denominator, that's what's actually on your unit circle. But if you rationalize the denominator, you'd be looking for, where does it equal square root of 3 over 3? And now we go to the unit circle and we come up with our answers. So, take a look. Tangent, we're looking for positive or negative 1 over square root of 3. Where's the first one? And if we work our way around, now I'm looking at all the handwritten ones. Well, here it is. Pi over 6, there's your first one. That's positive. Where's the next one? Yep, 5 pi over 6. There's a negative 1 over square root of 3. Where's the next one? 7 pi. There's another positive right here. 1 over square root of 3. And one more. 11 pi. And 11 pi over 6. Negative 1 over square root of 3. Okay? So in this case, because of the plus or minus, we end up with 4 answers. Okay? So let me put those down. We end up with pi over 6. 5 pi over 6, 7 pi over 6, and 11 pi over 6. And real quickly, going back to what we talked about before, just to make sure you understood what I was saying before. I had said earlier that we're going to just keep the domain between 0 and 2 pi. That's why we stopped at 11 pi over 6. In theory, I could keep going. I could, all right, and then I go, now then here's the next one, and then here's the next one, and then here's the next one. And we could just keep going around and around and around forever. We limited the domain so we don't have to do that, okay? So that's just a quick heads up. How we doing? Questions so far? Not too bad, right? Okay. It does get a little bit harder, but it's not nearly, like I said, what we were doing. All right, here's the next one. This one gets a little bit harder. Still very doable, especially, like I said, compared to what you've been working on for the last week. All right, first question. Factor or isolate? Factor. Now I've got a cosine squared and a cosine. I can't combine those. Those aren't like terms. This is a factoring problem. And hopefully now, after doing those trig identities at least a little bit, you recognize that this is a factoring problem. Okay? This is just a trinomial. So we're going to put our two sets of parentheses down. And you factor a trinomial the same 3 steps every single time. Step number 1. Factors of your first term, which in this case would be 2 cosine x and cosine x. Okay. 2 times 1 gives you the 2. Cosine times cosine gives you the cosine squared. There's your factors of your first term. Then, factors of your last term. 3 and 1. So, let's put this in here. 3, 1. And then the last part, you have to check the combination of the inside and the outside to see if you can get the middle term out of that. Okay? So if you check the inside, we get 3 cosine x. Outside gives me 2 cosine x. Can I get a negative 7 by that combination somehow? Nope, that doesn't work. Which means, what do I do next then? Yeah. I can't be anything other than 3 and 1. That's the only thing that multiplies to 3. But I might not have them in the right spot. So let's flip. Let's put the 1 here and put the 3 there, and then recheck the inside and the outside. 1 cosine. Outside gives you 6. You need a total of negative 7. What do the signs have to be? Negative and a negative. There it is. It is factored. Same 3 steps every time you factor a trinomial. Factors of a first term. Factors of the last term. Check the inside and the outside to get the middle term. Okay? Now, we factored, we have not yet solved. Now we do the zero product property. If I were to set this first factor equal to 0 and solve it like we did previously, we would get the cosine of x equal to 1/2. Set it equal to 0 and then solve for cosine. Second one, we would have the cosine of x equal to 3. And now you go to your unit circle. We'll start with the 1/2 here. Now you start taking a look at where are the answers. So in this case, if you take a look at your unit circle, where does the cosine of x equal 1/2? Okay, remember, you're looking for x coordinates again. So pi over 3, and the other one is down here at 5 pi over 3. Yep. There's your 2 answers for that part. That's where on the unit circle the cosine is equal to that value. So if we go back, we said pi over 3 and 5 pi over 3. There's 2 answers. Now we go to the other factor. Now, quick, and a couple things about the other factor. First part. Is 3 a value on, is that a unit circle value? No, we basically have a few different options. We're looking for like the 1/2s, the square root of 3 over 2s, the square root of 2 over 2s, 0 or 1. Okay, those are the ones you're really looking for. So when it is not on the unit circle, here's what you would do instead. Okay, and I'm going to have you do this. Instead, how do I solve for x? If you were just solving this, what would you do? Can't divide by cosine. This isn't cosine times x. There it is. The opposite of cosine is the inverse. So if you would take the inverse cosine of both sides, you would get the inverse cosine of 3. What I want you to do real quickly, take out your graphing calculator. There's 2 reasons I want you to have your graphing calculator out. That's one of the reasons. No, radians. So reason number 1. Oop, okay, I'll wait. First question. Based on the fact that these answers are pi over 3 and 5 pi over 3, if you're using your calculator, what mode should you be in?
Radian mode.
Radian mode. These are in radians. We're using radian answers. So make sure you hit the mode button at the top. Make sure you are in radian mode. And then you type in inverse cosine of 3. And what do you get? Error. This gives you an error. Anybody tell me why? This is the second reason why I wanted you to see this. It says domain. What's wrong with this domain? Think back to chapter 4 a little bit. Remember the answers we always said? You can only take the inverse cosine of things between -1 and +1. Remember back to that from the end of chapter 4? You can only take inverse cosine between 1 and -1. So in this case, you won't actually get any answers from that factor. Okay? However, let's say that this said cosine of x equals 2/3. Is 2/3 on the unit circle? No, it's not one of your unit circle values. But if you took the inverse cosine of 2/3, would you get an answer? Yes. That's why I wanted you to see this. 1, to discuss the domain part of it. And 2, anytime you end up with a value that's not on the unit circle, that's a calculator problem. Okay? Which you won't see a lot of. Matter of fact, the worksheet today, I don't think you see that at all. But the worksheet I'm going to give you tomorrow, you'll start to see some of this a little bit more. Okay? But I wanted to make you aware of it. How we doing, okay? Yeah. Okay. Next example. I think I've got this one and one more, and then that's it. All right, first question. Factor or isolate? This is an isolate. There's only a secant in that problem. So, add the 2 over. Secant squared x equals 2. Now what? Square root of both sides. Secant of x equals, and don't forget, plus or minus. And I would suggest, anytime there's secant, cosecant, or cotangent, go the one extra step to get it into sine, cosine, or tangent. So this is the reciprocal of cosine, which means I'm looking for where does the cosine equal plus or minus 1 over the square root of 2? But if I rationalize that denominator, what do I get? Square root of 2 over 2. So I'm looking for plus or minus the square root of 2 over 2. Where does the cosine equal that? Positive or negative? Should have 4 answers. What's answer number 1? Pi over 4. What's the next one? 3 pi over 4. What's the next one? 5 pi over 4. And the last one is 7 pi over 4. The square root of 2 over 2s are always at your pi over 4s. Okay. First quadrant, pi over 4. Second quadrant, 3 pi over 4. Third quadrant, 5 pi over 4. Fourth quadrant, 7 pi over 4. Okay. And there are our answers for this one. All right. Last one. This will be the hardest type of one you would see, at least for today. Which still isn't too bad. Again, especially compared to what you've been working on. All right, first question I have for you. Factor or isolate? Factor. So let's get this equal to 0 first. I'm going to take that 2 cosine squared and subtract it over to the left. Right? You could go the other way, by the way. You could take the sine of x, subtract it to the right, subtract the 1 over. Doesn't really matter. Either way. And now, based on some of the experience you've had with trig identities, what's the problem here? If I'm going to try to factor this, what's my issue? Yeah, I can't factor stuff that's got sines and cosines in it. We got to either get it to sines or we got to get it to cosines. Which? What'd you tell me? What'd you just say? Cosine squared is? A trig identity. What does cosine squared equal? 1 minus sine squared. Let's do a substitution. Take cosine squared out. Put 1 minus sine squared in its place. So you're just substituting in a trig identity. So that now I have sines, and now we're basically back to algebra again. I need to take this -2, I'm going to distribute that. So we have 1 plus the sine of x, minus 2 plus 2 sine squared x. And now if we clean this up a little bit, again, a couple of heads up just in general. So on some of the trig identities in the last few days that you've been working on it when you were factoring, a lot of times I told you, just if the sine squared is at the end, leave it there and just factor as is. But the reason I always had that was because it was negative. It makes it harder if you take the first term and make the first term negative to then factor. Okay? This is not negative, so I'm actually going to rearrange this and write, I'm going to put it like you would a quadratic equation, where the x squareds come first, then the x's, then the constants. So I'm going to put the 2 sine squared first. If that was negative, I would leave it right where I'd leave it at the end. Okay? I generally don't, I would not want the negative out front. I think it makes it harder, personally. Okay? I'm going to put the sine of x next. And then the last part, you got your constants. We can combine like terms. 1 minus 2 gives you -1. And now, we're right back to factoring again. We're just like a couple of problems ago. Back to factoring a trinomial. Okay. What's going to go in the first spot in each factor? What are my factors of the first term? 2 sine x and sine x. Okay. Factors of the last term. In this case, it's nice. You know it's got to be 1 and 1. And now we just have to figure out the signs. Inside gives you 1 sine x. Outside gives you 2 sine x. From that combination, you need a positive 1. So that means I need that to be positive and that to be negative. You'll get a negative sine x, and you will get a positive 2 sine x. And now we are right back to zero product property and finish this problem off. This factor, if you set it equal to 0 and solve, you'll end up with the sine of x equaling 1/2. This one will end up with the sine of x equaling -1. And we go to our unit circle, and now we start answering the questions. Where does the sine equal 1/2? Where's the first one? Pi over 6 is the first one. Where's the next one? Somebody said it. Stita, was that you? 5 pi over 6. Are there any other? Nope. Now where this positive, and this one's not a plus or minus, so there's your 2 answers from that part. How about the second part? Where does the sine of x equal -1? What is it, Trent?
Pi over 2.
Not pi over 2. That's where it would equal 1. 3 pi over 2, that's a 3. On your unit circle, that's a 3. Just so you know. 3 pi over 2. Okay? 3 pi over 2 is the bottom, 270 degrees. So in this case, you end up with 3 answers. Okay. Like I was telling you, whole lot simpler for now at least. Okay. Again, tomorrow will be more difficult, but it's not going to be insanely difficult. Okay. It gets a little bit more difficult. One quick heads up just in general, as it relates to your assignment in a second, you'll see it. I didn't have it in any of the examples. But let's say we ended up with, let me go back to this problem here for a second. Let's say I ended up with the secant squared equal to a fraction. And then I took the square root of both sides. How do you take the square root of a fraction? Square to the top, square to the bottom. You just split it up into 2 parts. Okay? So just a heads up, and the reason I mention that is you're going to see that on the assignment. If you ended up with a fraction and then you take the square root, take the square to the top, take the square to the bottom, do it separately, and then go from there. Okay? Just a heads up. All right. So, assignment for today, you've got a solving trig equations worksheet. I'll get you that. Answers are on the back side. And with the rest of the time, you got some time to work and ask some questions.
Who's that nurse? Who's that Pelican?